We're going to use the definition of the derivative to differentiate f of x equal to the square root of tangent of x. To do it, we'll need the following results. The first one is a trig identity, which is tangent of alpha plus beta is equal to tangent of alpha plus the tangent of beta divided by 1 minus tangent alpha times tangent of beta. And the second result we'll need is that the limit as h approaches 0, tan h over h is equal to 1. So recall the definition of the derivative. That's the limit as h approaches 0, f of x plus h minus f of x divided by h. And in our case, this will be the limit as h goes to 0, square root of tangent of x plus h minus the square root of tangent of x divided by h. Okay, first thing we're going to do is multiply this limit by the conjugate of the numerator, which is square root of tangent of x plus h plus the square root of the tangent of x divided by the square root of tangent of x plus h plus the square root of tangent of x. And this will allow us to free up the numerator. That is, no radicals in the numerator, which is very important. The numerator now looks like this. It's tangent of x plus h minus the tangent of x. And now the denominator is h times the square root of the tangent of x plus h plus the square root of tangent of x. And this is equal to, now we can use the trig identity on tangent of x plus h. So this is the limit as h goes to 0, tangent of x plus tangent of h divided by 1 minus tangent of x times the tangent of h minus tangent of x, and all this is divided by h times the square root of tangent of x plus h plus the square root of tangent of x. Now what we need to do in the numerator is get a common denominator, so we'll multiply the tangent of x here by 1 minus tangent of x times tangent of h, and of course divide this by 1 minus tangent of x times the tangent of h. And let's see, the next step then is to have the numerator simplified. So this is h goes to 0. We have tangent of x plus the tangent of h. Since we have a common denominator, tangent of x minus tangent of x times 1 would be minus tangent of x. Now we can see that these cancel. And then minus tangent of x times minus tan x times tan h would be plus tangent squared of x times tangent of h. This is divided by 1 minus tangent of x times the tangent of h, and divided by, again here, by h times the square root of tangent x plus h plus the square root of tangent of x. So let's do some simplifying again. First of all, the numerator we can factor out. We still have the limit as h goes to 0. We can factor out tangent of h, and then we have 1 plus tangent squared of x. And then this is divided by, the two denominators can be combined, So it's 1 minus tangent of x times tangent of h times h times the square root of tangent of x plus h plus the square root of tangent of x. And now let's break this up into the product of two limits. So first note that 1 plus tangent squared of x is secant squared. The first limit will be limit as h goes to 0 of tangent h over h. And the second limit will be the rest. So this is limit as h goes to 0. This is times. We have 1 plus tangent squared, that's secant squared of x. In the denominator, we have 1 minus tangent of x times tangent of h times the square root of tangent of x plus h plus square root of tangent of x. So now this, what I'm circling, this limit is result number 2. This limit is 1. And now let h go to 0 in the second limit. So as h goes to 0, this tangent of h right here goes to 0. So tan x times 0 goes to 0. We just have 1. And here we have square root of tangent x plus h. That becomes square root of tan x. And then, of course, plus another square root of tan x. And so what we have left is secant squared of x in the numerator. And in the denominator, we have 2 times the square root of tangent of x. And that is the answer. So let's summarize briefly. We started with the function f of x equal to square root of tangent of x. After applying the definition of the derivative, we found that f prime of x is equal to secant squared of x divided by 2 times the square root of tangent of x. For more videos, visit www.mathprepvideos.com.